Hi guys, this is Pratik. Welcome back. Welcome to Physics Simplified. I'm very happy to announce that we have covered almost 95% of syllabus of 11th and 12th. I think 98% you can take because the two topics which are remaining is out of the two. One is communication systems, another is Einstein relativity. Einstein relativity is not there in any of the syllabus. It is there in S.C. Verma, and you know Padma Shri S.C. Verma has really beautifully written about Einstein's special theory of relativity, which we'll talk about in next video. Next topic. Probably this will take a video or two only. Communication system. So communication system is basically to tell you the whole summary. I chose this topic because I wanted to tell you how the communication happens. So in this digital era where the world has become globalized because of communication, it has happened because we were and we are and we will able to harness the power of electromagnetic radiations, and through which communication happen. And remember guys, electromagnetic radiation travels almost with a speed of 3 into 10 to the power 10 meter per second. 3 into 10 to the power 8 meter per second, which is the speed of light, right? And it is just to give you a understanding that how this speed, this enormous speed, has helped us to communicate with each other almost instantly, is that the time taken by the light, which is a basic natural source of electromagnetic radiation, it contains all the spectrum, that takes 8 minutes 20 seconds to reach the earth, and the distance between earth and your sun is almost 150 million kilometers. And if you divide that with the speed of light, you get this time of 8 minutes, which is basically 500 seconds. Now, I compared that with the circumference of the Earth. The circumference of the Earth is around 40,000 kilometers. And if you divide that distance with the speed of light, you will be shocked that in 0.1 second, the light will be able to travel across the circumference. So that's why it is less than, it's 1/10 of the second where it can. So think about if I'm making a call to you, if you're in America, you are probably 5,000 kilometers away from me, and the 5,000 kilometers is nothing for the speed of light, and we almost instantly talk, right, internationally as well. Similarly about internet, about mobile communications, so everything has become possible because of the speed of light. If this is just imagine that if the speed of light would not have been that which is there, well, we would not be able to talk almost instantly to each other, right? So that's the beauty of electromagnetic radiation. In here we will understand the communication system, and basically for any communication system, these ingredients are required. So what are these ingredients? Suppose you write something on your laptop, right? You write this word, right? Star marked word. Then that is your basic input. This gets converted into a message signal. Message signal generally in electric form, because that's what you have to create for the machine to understand. Machine doesn't understand A, B, C, D. It understands electric signal. Obviously, this transformation is done during a transducer, whatever the term is, transducer. This is basically a semiconductor which has a lot of transistors, and it converts through logical gates all this information into a binary code of 0, 1, 0, 1, 0, and this 0, 1, 0, 1 combination is a form of a signal. So if it is 0, it is low voltage. If it is 1, it is high voltage. So likewise, a rectangular sort of a curve is more like this, right, of the voltage with respect to time, that goes into your message signal, right, in a form of electric form. A transmitter is basically where the electron do vibration. It oscillates. Remember guys, as we talked about Mr. Electron was the one when it is standing, it creates electric field. When it moves, it creates magnetic field. When it moves with a constant velocity, obviously, and when it starts accelerating, it starts producing electromagnetic radiation. This is what we understood as well in Maxwell equation. The second video, which I'll give a link here, just go and watch that as well. The Maxwell second video, I talked about how this electromagnetic radiation is released. So we will just take a snapshot of that as well here. So here, if you see, we are into transmitter, right, where we are trying to produce electromagnetic signal. Now this is how the electric field will be. When they come close, the electric field will be like this. When they further come up close, the electric field will be like, you know, like coming like this, gets distorted. As they move apart, the electric field, new electric field comes into picture, and this portion gets detached and it goes something like this. And this is your electromagnetic signal. Now this electromagnetic signal, the transmitters release into air. It goes in all direction. Now you can have a parabolic transmitter where you give a direction to it. It would probably be a concave mirror where you put the source at the focus and all the lights goes parallel, and you can give a direction as well. So that's why satellites are parabolic in nature. That you can definitely do, give a direction to it using a parabola. Then that signal goes into the medium, which is basically your space, the atmosphere, right? That is your medium and channel, and here your electromagnetic waves travel as E is equals to E naught sine omega t minus kx. This is generally for analog signals. For digital signals, it travels in a form of high voltage and low voltage. Even I don't understand a lot about this. I am not an engineer. I am not an electric engineer. Even if I had, if I would have been, then I would have told you. But if I'm not an electric engineer, so not electronics engineer, neither computer engineering, I am a chemical engineer, which I am not too proud of, but it's okay. So this is high voltage, and this is the kind of signal which travels in the wave. It reaches an antenna. Now this antenna we discussed in inductance, in capacitance, and in alternating current. I will give you a link of alternating current here as well. So go there. I have discussed this as well there. It's also there in Maxwell's second video, Maxwell's equation second video. What happens here is there's an antenna. Now this antenna has a LC circuit, right? LCR circuit, and the omega, if you remember, is given by 1 upon under root LC, and this is a omega for a resonance to occur. Now if I change my C, I can change omega, right? So this omega is in control. The light which is coming, the omega is here. If these two omega syncs, my electron, my current will be oscillating in with the same omega, and that creates sort of an electrical signal which, using a semiconductor, using a transistor which has logic gates of 0 and 1 binary, can be converted to my original signal, which was this. This is not intended to you. This might be something which you can write for your lot of people. This is a very relevant, common expression that we use here, and it doesn't go against Hindi culture. Definitely not against Hindutva, but it's censored, right? It has got stars here, so there's nothing to be worried about. So this is how the whole signal which gets generated by the electron movement, the electron wiggles, create electromagnetic radiation, it travels, again the electron wiggles, it receives that signal, somehow it's converted into the old messaging, and whatever you have written here on a laptop will be received here. This is an example of digital signal. This might also be the case for somebody who is trying to transfer, do a transfer of sound waves, like in radio, right? So basically, your communication happens in two forms. One is point to point, which is P2P. The mobile and laptop are the most important examples of this, but nowadays with Facebook broadcasting, Facebook Live, Skype, your FaceTime in Apple mobile, all this is also can be used for broadcast as well. So the definition has blurred, but I'm talking about it, few decades back. Broadcast, radio and television are a form of broadcast. Now television is getting redundant because of the entertainment is being shifted to digital, and that's also a very democratic process, because the big V's of existing entertainment industry is facing competition from digital, which is a very democratic medium. So that's a positive side of technology nowadays. And in fact, if you see the media of India, which is India going through a media crisis, and this will continue to happen so in future as well, the hope that we have of digital media is from the channels, online channels like Lalan Top is there, which is quite objective, Quint is there, right? So these channels give you objective information nowadays. So obviously this communication is very important, guys. Communication is what makes us alive. There's a misuse of communication as well, which is happening a lot of like IT cell of BJP, or the fake news, or WhatsApp University. There's a lot of fake news which are and what is the problem with people? When they see something on WhatsApp, they take it as it is. You don't even go and verify that. Not even a brief verification of logic in that factual matter which is given to you. They just take it as it is, and that creates a problem, because when you there's a one theory, right? If I tell you a lie first time, you will catch it and say you're lying. But if I keep saying that lie again over a period of time, the psychology is such that of a human that it starts believing as a truth, and then it starts projecting as a truth. So that's how you change lies into truth, right? So communication has both the positive impact and negative impact, and that goes for everything, I guess. The positive and negatives is a part of like positive and negative charge, or it's a part of life. So you have to deal with it, and that's a reality. So now, have I given you a brief understanding of how signal transfer happen? Now what we'll do is, I want to further elaborate on this. You keep this picture in mind, okay? Probably I will take a snapshot of this, which seems like a good idea, and put it on a side. Plus, I will be putting a snapshot of 2 or 3 pictures which I have made to make this simple. So just how much time has passed? It's 12.5 minutes, 12.30 minutes. So I can wait. I'm pausing the video. We will continue. Just give me a while, and you will have this in a form of picture and a lot. Just wait for a while. Hi guys, so in here I don't need to rub this. I'll keep it as it is. But guys, this is just in background. I will speak from here, and in this space I am showing you right now the table, right? And this table is in my hand as well. So you concentrate on table. This table is about the frequencies, and I have mapped the complete spectrum from radio waves, if you can see, to IR rays, to visible spectrum, to ultraviolet rays. I told you in the beginning, guys, frequency is very important. It actually defines what your electromagnetic radiation is. Higher the frequency, the more energy it carries. From the formula E is equals to h nu of a photon, if you remember. So if my frequency, since electromagnetic radiation is a wave in itself, it's a transverse wave, and it doesn't require a medium to propagate itself. It does it by changing the electric field and magnetic field. Its frequency, its energy is totally dependent on its frequency. So if you see this table, see it for once and all. Try to compare this with the very relevant thing that is happening in our life, is the data. Right, so data was initially measured in bytes. There was a time when the internet used to supply internet at a speed of kbps, kilobytes per second. So that's a second level. Then you have megabytes coming into picture. Now we have 10 mbps, 15 mbps speed, 1 gbs speed also is there now. So compare that with these hertz. So you see, there's the first is 1 hertz and 1 kilohertz and 1 megahertz, 1 gigahertz, 1 terahertz, 1 petahertz and 1 exahertz, right? So this is how I have divided it, so you can visualize likewise. If you see first thing, 1 byte, if you go from 1 byte to 1 gigabyte, or 1 hertz to 1 gigahertz, which is basically 1000 megahertz, you will find radio waves in there. And the wavelength, so if you go into a second column where I have written the wavelength as well, right? So there, that's a wavelength spectrum. So for radio waves, you see the biggest wavelength could be of 3 lakh kilometer, and obviously that 3 lakh kilometer cannot be transferred. It will require a lot of energy to pump it up and send across, but that's a hypothetical figure that we have, 3 lakh kilometer, and it goes down to 30 centimeter, or you can take 1 meter for the sake of simplicity. So it's in 1 meter to 3 lakh kilometer, that's the range of your radio waves. Now going down, when we go into gigahertz, so from 1 gigahertz to 1000 gigahertz, that's where you now are, you're hearing 1.2 gigahertz, 3 gigahertz, in spectrum you are hearing all these words. So this gigahertz is, if you see the wavelength of it, it varies from 30 centimeter to 0.3 millimeter, and infrared comes into picture. If you go further down, from 1 petahertz to 1000 petahertz, the wavelength varies like 300 nanometer to 0.3 nanometer. So the visible spectrum is between 350 nanometer to 750 nanometer approximately, right? And in this range of visible spectrum is there. Now if I further increase the frequency or lower the wavelength, I will get into exahertz and petahertz of higher magnitude. You will get into your ultraviolet rays and X-rays. Now ultraviolet rays is prevented by the ozone layer, which is getting depleted by the climate change problems that are happening in the world. So this ozone layer, if it gets depleted, will not prevent the ultraviolet rays from sun to reach us, and in that case it will be harmful for us. So you can correlate from there that ultraviolet rays are the most harmful rays in terms of frequency. They are high energy rays. Now if you go beyond now to the rightmost part of the table, you will find that I have written the mode of communication as well, not medium of communication as well, through which these frequency waves can be transferred. So for low frequency, coaxial cables will do. If you increase the frequency to 1 kilohertz to 1000 kilohertz, a free space is what we are looking at, where we will transfer the signals. Beyond 1 gigahertz, so if you talk about your 1G, 2G, 3G, 4G, 5G spectrum, that lies mostly from 1 megahertz to 1000 megahertz, probably 3000 megahertz, which is 3.5, 3.6 gigahertz, right? So till there your 1G, 2G, 3G, 4G varies, beyond which you would require optical fibers starting from 1 gigahertz to transfer, right? So this is a basic understanding what I have got from the data which I have collected from NCERT itself, from the same chapter, communication system, and I have tried to collate that so as to give you an understanding that what kind of medium is required, what kind of rays are there for a particular frequency, and what sort of content is like that. So you see, if you're sending a SMS or voice, it will probably be a signal of a very low frequency ranging from 1 hertz to 1000 hertz. If you're sending a music in air, it goes to 1 kilohertz to 1000 kilohertz. And if you're trying to send a video or doing a live talk, you would require to send the signal from 1 megahertz to 1000 megahertz, which is there in mostly 3G, 4G, 5G. It is possible, very much possible, right? So this table was there, guys. So I'm removing the table now. Okay, this table must have given you the frequency bandwidth and in what frequency, what is the medium, what is the kind of a wave, what sort of content is sent in which kind of, you know, frequency. Now I am again giving you another snapshot. Now see this snapshot. This is basically the down portion is the earth portion, right? And the markings which I have done, you can see the markings, right, on the earth. This is the earth surface, right? And the markings which I have done, each marking, the least count of that marking is 500 kilometers. So there are overall 10 markings, approximately 10 to 12 markings, and I think there are more than that. One second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think 20 markings are there almost, and which is basically equals to 10,000 kilometers, right? If each marking is of 500 kilometers, the overall radius, the overall circumference of the earth is around 40,000 kilometers. So this in a way represents the actual picture if I had drawn to a scale of, you know, this is scale. So this actually, it represents this kind of a movement. Now if I want to transfer signals of in a very low range, so you can see in the middle, right, in the middle, if you can see, there are two towers, and which is basically the magnification of the middle point. Can you see the middle point here? How can I show you? Because if I put it, my hand will go behind. Okay. Can you see just exactly in the middle? There is, oh, I can show you in this way, right? Now see, now you can see, right? I've removed that and I'm putting this. So this is the point I'm talking about. Here, this the two towers are the magnification of these two. And here the distance, if you see, is around 300 meter to 1 kilometer. In this range, if I want to transfer electromagnetic radiation, my frequency would be less than 5 megahertz. Remember, guys, we will maximally, for all the real purpose scenario, our communication happens from 1 megahertz to 1000 megahertz. It's in megahertz, guys. So we will be talking in megahertz term only. That becomes simpler for us, which is equivalent to saying MBs में हम बात कर रहे हैं. We are not talking in GBs. So if you see here, less than 5 megahertz gets transferred in ground waves for a very small distance. If I want to increase the distance further, now you see this portion, right? Now see this portion in the slide, in this image. You see, this is an exaggeration of the 500 kilometer distance. So these two points I have exaggerated here. And due to exaggeration, if you see, the distance of 500 kilometer can be transferred using sky wave. Now what are sky waves? The first one was the ground wave, second is sky wave. Sky waves basically transfer from 5 megahertz to 30 megahertz, and they do so by reflecting the electromagnetic wave from the ionosphere, which contains iron. Obviously, if you go up, right, your atmosphere decreases, so you are going from a denser medium to a lighter medium, and when you go from denser medium to lighter medium, total internal reflection is possible. So it is generally sent at an angle, desired angle, such that the angle is greater than critical angle. So for that, maximum of the rays can get reflected and can be converged to a tower which is 500 kilometers from your range. That is your sky wave. Third way, which is the maximum, that is what exactly happens for international communication. If you're transferring a wave from here to America, which is 5,000 kilometers of distance, now you see this area. See this area? This area is your, you can see here now, this area is for your, I've not written, ground wave, sky wave, and space wave, right? So these are space wave, and two sort of things happen here. First, the communication happens through via satellite. Signal is sent to the satellite, which is stationed somewhere 100 kilometers from the surface of the earth. The signal is sent there. Maximum of the satellites are between 500 kilometers to 1000 kilometers. Starts from 100 kilometers as well. So in this range, the signal is sent and it's come back, it makes a comeback. In all this, remember guys, the speed of light is 3 to 10 to the power 8 meter per second, and I gave you a comparison before that this is a very small distance for light. Okay, so when the light goes to this satellite, it comes back. For certain frequency which is greater than 40 hertz, sometimes your line to line LOS communication is required. You can see the term LOS, basically line of sight communication, which means straight communication is required. So in that case, a curvature is there, right? And through that curvature, we have to ensure that the height of the other tower is sufficient enough to give you the range, right? So that it can catch the range. So this is called space wave. Okay, so I have given you an idea how, so I am removing this now. So I have given you an idea how this happens, and going forward we will get into details as well in the next video. I will end the video here, the first video, and in the second video these pictures will come whenever they are required in small spaces, so you get a context. I will get into signal strength, I will get into bandwidth, I will get into details now. Not very much, but the next video will be the last video itself, and you will get a proper understanding of how this communication system works. All the nuances, attenuation, so you have to increase the frequency, basically the energy of a signal to get it transferred over long distances. How that is done, what is the small formulas, you will try to cover in the second video itself. So wait a while. I hope you have got a basic clarity of how communication system works on Earth in this universe. Wait a while. We'll meet in next video.